Imagine you're holding a single tiny seed in the palm of your hand.
Okay.
You look at it, and I mean, it just looks like a speck of dust.
Right.
Nothing special at all.
Right.
But then someone taps you on the shoulder and says, look closer. Because inside that one seed is the literal mathematical blueprint for the entire universe.
Which is a massive claim.
A completely insane claim. And I'm not just talking about, the physical universe of stars and galaxies. I mean, the rules of pure logic, the hard limits of artificial intelligence, the very nature of cause and effect.
Basically, the underlying code of reality.
Exactly. And honestly, this is the part that genuinely kept me awake last night. A rigorous mathematical proof of why being an all-knowing, omniscient God would actually be incredibly boring.
Yeah. It really does sound like the premise of a sprawling, high-concept science fiction novel, doesn't it?
It totally does.
Because we are so conditioned to think of physics and philosophy and pure mathematics and computer science as these completely isolated domains.
Right, like they don't talk to each other.
Exactly. So the idea that you could compress the chaotic, sprawling entirety of reality down to a single, elegant string of code, well, it seems impossible.
It sounds like pure fiction. But we are stepping completely out of fiction today and into the absolute bleeding edge of mathematical reality.
Yes, we are.
Because for today's deep dive, we have been handed this massive, staggering repository of files, and I really want to be clear with you about what we're actually looking at here.
It's important context.
Yeah, because this isn't a stack of academic PDFs or like a philosopher's musings. We are looking at formal logic and computational proofs written entirely in the Lean theorem prover.
Which is a crucial distinction to make right out of the gate.
Right. Explain Lean for us.
So for anyone who hasn't worked with it, Lean isn't just a text editor. It's a programming language that is specifically designed to mathematically verify proofs.
Like a referee.
Exactly like an incredibly strict referee. It does not allow for fuzzy logic. It doesn't care about your rhetorical leaps, and it definitely won't let you hand-wave away a missing variable.
It's just cold, hard math.
Right. If you write a proof in Lean, and the code successfully compiles, the math is indisputably structurally true.
It's an automated truth checker. And this specific stack of code attempts to do something just breathtaking.
It really is.
It builds a complete mathematical architecture of reality based on something the author calls the God formula.
And a fundamental underlying concept called the Kleneman.
Right. Now, it is a profoundly dense repository.
Very dense. We're talking about thousands of lines of .lean code, variable declarations, recursive functions.
And obviously, our goal here today isn't to just read a textbook of raw code to you.
That would be excruciating.
It would be the worst deep dive ever. What we are going to do is extract the mind-bending philosophical and physical implications locked inside this math.
We're going to connect the dots across all these files.
Right, to look at what essentially amounts to the underlying operating system of reality.
And to boot up an operating system, you have to start with nothing.
Or rather, the impossibility of nothing. Which brings us to the core equation driving this entire framework. It's found in a file called cosmogenesisbigbang.lean.
The foundational file.
Right. This file introduces the God formula. I'm going to read it out slowly, and then we're going to break it down.
Go for it.
The formula is W equals R minus the minimum of V and R plus 1.
So W equals R minus the minimum of V and R plus 1. I mean, on the surface, it's just basic arithmetic.
Yeah, and I was looking at this trying to wrap my head around it without having a whiteboard in front of me.
It helps to visualize it.
It does, and the best way I could visualize it is like a cosmic accounting system.
Okay, I like that.
So imagine R is your budget. It's the total pool of resources you have to work with. And V represents your rejections or your expenses, like the things you are throwing away or spending.
That's a really solid mapping.
And the middle part, the minimum of V and R, that's just a fail-safe.
Right, to keep things bounded.
Exactly. It means you can't spend more than your total budget.
Right. If your budget is $10, the absolute maximum you can subtract is $10.
You can't spend 15. You just can't.
Nope.
But the real kicker, the thing that changes this from a simple accounting trick into a literal universe-generating engine is the end of the equation.
The plus 1.
Yes. No matter what your budget is and no matter how much of it you spend, the formula tacks on a plus 1.
Which is massive.
It structurally ensures you always fundamentally have something left over. You never, ever hit absolute zero.
And that plus 1 is the absolute crux of everything we're going to discuss today.
Everything.
In the source material, it's referred to as the Kleneman.
Which is a cool word. Where does that come from?
It's a term originally from ancient atomic theory. It
Hmm.
basically means a swerve. Or sometimes in the text, it's just called the sliver.
The sliver. I like that.
What is truly fascinating is how that bigbang.lean file applies this to the concept of true nothingness.
Okay, let's get into that.
Suppose we want to model a state of absolute, pure nothingness, a state before the Big Bang, before any matter, before any observer at all.
Just total void.
Right. How would you model that in your accounting analogy?
Well, I'd have a budget of 0, so R equals 0.
Okay.
And my expenses, V, would also be 0. Nothing in, nothing out. Total void.
So logically, you'd expect the final tally to be 0, right?
Yeah, 0 minus 0 is 0.
Right. But run that through the God formula.
Oh, I see.
0 minus the minimum of 0 and 0 plus 1.
The output isn't 0.
The output is 1.
Wow.
The theorem prover mathematically verifies that absolute true nothingness is structurally impossible in this framework.
Because of the Kleineman.
Exactly.
Mhm.
Even when the universe's budget is entirely empty, the formula forcefully outputs a 1.
The Kleineman, the sliver. So it's literally saying the universe is mathematically forced to exist.
Realistically, it has no choice.
That's incredible.
And what's really cool is how this maps beautifully to actual observed physics.
Oh, really? How so?
The text connects this unavoidable output of 1 to the physical concept of vacuum energy, or the zero-point field.
Right, I've heard of that. That's quantum mechanics, right?
It is. In quantum mechanics, even if you have a complete vacuum, like imagine a sealed box cooled to absolute 0 with every single particle pumped out of it.
Just totally empty.
You'd think it's empty, but there is still a baseline fluctuating energy inside that box.
Because the universe literally cannot tolerate a true 0.
Exactly. Existence isn't some random accident or like a lucky roll of the cosmic dice.
Right.
In this framework, it is a structural mandate of the mathematics. The universe at R equals 0 and V equals 0 is completely saturated by this irreducible plus 1.
Okay, so existence is mandatory. We have our baseline vacuum energy of 1.
Yes.
But, I mean, a fluctuating quantum vacuum is a long way from the complex universe we live in.
It's a very long way.
Getting from a tiny speck of vacuum energy to, galaxies and stars and us sitting here talking into microphones that requires monumental growth.
Huge growth.
And that brings us to an incredibly trippy file called bootstrapcosmology.lean.
Oh, this one is fascinating.
It asks a really simple what-if question. What happens if you take the output of the God formula and feed it back into itself as the new budget?
The text calls this entering the bootstrap tower.
The bootstrap tower.
It's a process of self-application. Let's actually trace it out.
Let's do it.
We just established that at the very bottom level, with a starting budget of 0, the output weight is 1. That's the ex nihilo creation event.
Right. Out of nothing comes 1.
So now we take that output, the 1, and we say, okay, congratulations, you are the new budget for the next round.
Level 1.
So at level 1, your budget R is 1.
Okay.
If we evaluate the maximum possible weight by assuming 0 rejections, just to see the ceiling of the formula, it becomes 1 minus 0 plus 1.
Which equals 2.
Right. So the output of level 1 is 2.
And then the 2 becomes the budget for level 2.
Exactly. So R equals 2.
The formula becomes 2 minus 0 plus 1, which equals 3.
And then 3 becomes 4, and 4 becomes 5.
Ad infinitum.
Yes. By simply feeding the God formula's ceiling back into itself over and over, you perfectly reconstruct the natural numbers.
Okay, stop right there, because I want to make sure I'm really getting this. Is this what mathematicians call Peano arithmetic?
It is, exactly.
Okay.
Peano arithmetic is the foundational set of axioms for the natural numbers. It's built on what's called a successor function.
Right, basically the rule that every number has a number that comes exactly after it.
Yes. What this lean code proves is that Peano arithmetic isn't just some abstract concept invented by a 19th century mathematician.
It's not just a human invention.
Right. It is the bootstrap tower of the God formula. Arithmetic isn't something humans discovered. It's procedurally generated by the Kleineman.
Procedurally generated. Okay, that's the perfect analogy.
How so?
Think about a video game like Minecraft or No Man's Sky.
Oh, wait.
Those games don't have artists sitting there drawing every single tree or star by hand.
That would take forever.
It would be impossible. They use a single mathematical seed, just a short string of numbers.
Right.
You plug that seed into an algorithm, and the algorithm procedurally generates an entire infinite universe with mountains and oceans and caves.
That is an excellent way to conceptualize it.
What this code is saying is that the +1 is the seed, And the natural numbers are the procedurally generated universe.
That's exactly it. And the text takes this procedural generation and applies it directly to cosmology.
Okay, how does that work?
Because with each step up that tower, from 1 to 2, 2 to 3, the output is expanding by a constant rate of exactly +1.
Which maps to the expansion of the universe.
Yes. And this mathematically elegantly resolves one of the most frustrating headaches in modern physics, the cosmological fine-tuning problem.
Oh, right, because physicists look at the cosmological constant, the invisible force driving the expansion of the universe.
Right, dark energy.
And they realize that if it were even a microscopic fraction larger, everything would have blown apart before stars or planets could ever form.
It would have just ripped apart.
And if it were a tiny bit smaller, the whole universe would have just collapsed back in on itself in a big crunch almost immediately.
It appears impossibly, suspiciously fine-tuned for life to exist.
Like someone dialed it in perfectly.
Exactly. Physicists have agonized over why this constant is exactly the value it is. But according to bootstrapcosmology.lean, there is no fine-tuning.
Wait, really?
The constant isn't a knob that someone carefully dialed to the perfect setting. The text proves that the cosmological constant of the God formula is structurally exactly 1.
It's just 1.
Yes. It doesn't depend on the size or age of the universe.
So asking why the constant is perfectly tuned is basically asking the wrong question.
It's like asking why a triangle has 3 sides.
Right.
You aren't discovering a miraculous coincidence. You were just observing the definition of the structure itself.
The expansion rate couldn't be anything else because the +1 is fundamentally what the universe is made of.
Exactly.
Which is a massive paradigm shift. But, as I was reading this, I kept thinking, okay, having a universe that expands is great.
Sure.
But a universe isn't just empty space getting steadily bigger.
No.
It has texture,
Yeah.
It has physical structure. The
Sure.
protons have specific sizes. The force that holds atoms together operates at very specific distances.
Right.
So if this +1 equation procedurally generates the whole universe, how does it build the actual physical scales we see under a microscope?
And that perfectly bridges us from pure mathematical generation into actual physical reality.
Okay, let's cross that bridge.
The repository tackles this in a file called bythoscale.lean.
Bythos scale.
Right. It introduces the concept of the dimensional ladder.
Huh.
The argument here is that the universe doesn't just spew matter randomly into the void.
It's organized.
Highly organized. It follows a strict dimensional hierarchy. Every time you step up a rung on this ladder, meaning every time you add a dimension, it dictates a specific physical scale.
Okay, walk me through this ladder. What are the rungs?
So the dimensional ladder starts at the absolute bottom, dimension 0. The code names this bythos.
Bythos. And physically, what is 0D bythos?
It corresponds directly to the Planck scale.
Which is the smallest measurable length in the universe.
Exactly.
Roughly 10 to the negative 35th meters. It's basically the pixel size of reality.
That's a great way to put it. From 0D bythos, the next emanation up the ladder is 2D.
Okay, skipping to 2D.
Right, which they call barbello. This maps to the subfemtometer scale.
Okay.
Then you jump to 4D, which they explicitly call the proton level.
The proton level.
And it maps perfectly to the femtometer scale, which is the actual physical radius of a proton.
Wait, so the size of a proton is dictated by the fact that it sits at the 4D level of this ladder?
Yes, the geometry dictates the size.
That is wild.
And it continues. At 6D, you have the primitive level, which the code maps to the range of the strong nuclear force.
The force that holds the nucleus together.
Exactly. And by the time you reach 11D, named Kinoma, you are at the atomic scale, the Bohr radius.
Okay, I have to push back hard on this.
Go ahead.
Because it is one thing to sit at a desk, draw up a neat little ladder of theoretical dimensions, and give them cool esoteric names like Bythos and Kinoma.
Sure.
It's another thing entirely for those clean theoretical concepts to perfectly match the actual chaotic empirical measurements of our physical universe.
It's a big claim.
Right. So when they say the jump from the 0D Planck length to the 4D proton size spans roughly 19.7 orders of magnitude, is that an exact match?
It's a very valid question.
Or are they just taking a messy real-world number and rounding it to make the math look pretty? Because people do that all the time.
They do, but it is a vital question, and the proof in bythoscale.lean is completely rigorous, specifically to address that skepticism.
Okay, how do they prove it?
The code doesn't use floating point approximations.
Which is where you usually get those rounding errors that fake a match.
Exactly. It uses strict integer math to calculate the ratios. The model mathematically dictates that the structural gap, the first emanation gap from the 0D point to the 4D level, must contain exactly that proportional distance.
So it's not a coincidence.
Not at all. The 19.7 decade gap isn't a rounded coincidence. The code proves it is geometrically mandated by the dimensional step. The dimension literally is the scale order.
So the math is literally projecting the physical sizes of subatomic particles strictly from their geometry.
Yes.
That is just mind-blowing. But the code doesn't just stay in the subatomic realm, does it?
No, it scales all the way up.
To the size of the entire observable universe.
Yeah.
And to handle that, it introduces a completely new metric of time in a file called cosmicprojection.lean.
Right.
Because the timeline of the universe here isn't measured in years, it's measured in something called Lorenzos.
Lorenzos, yes. A Lorenzo is defined as approximately 8.6 billion years.
Which, side note, who gets to name these cosmic metrics? Lorenzo sounds like a guy who makes a really good espresso down the street, not a unit of cosmic time.
It does sound a bit casual.
But I digress. Why 8.6 billion years? Where does that number come from?
It ties directly back to the growth rate. The text proves that the universe grows by a factor of phi per Lorenzo.
Phi being the golden ratio, roughly 1.618.
Yes. It's basically the Fibonacci spiral applied directly to the expansion of spacetime.
Wow.
So if the universe multiplies its scale by 5 every 8.6 billion years, the metrics they derive from this are startling.
Startling is an understatement. I was reading this and I had to put it down for a second.
It's a lot to take in.
If you run that phi per Lorenzo growth rate forward, the current age of our universe works out to be exactly phi Lorenzos old.
Which is approximately 13.8 billion years.
Which perfectly matches our best empirical observations of the universe's age.
Yes, it does. And furthermore, at phi Lorenzos old, the universe is projected mathematically to be 93 billion light years across.
And once again, that perfectly matches the observed diameter of the visible universe.
It's an exact match.
But here is the calculation that gave me absolute, pure existential dread.
Oh, the future projection.
Yes. Because if this mathematical engine is perfectly charting the past and the present, you can use that exact same phi per Lorenzo growth rate to project into the future.
Naturally.
And the code explicitly calculates the timeline for the death of our sun.
Right?
According to this framework, our sun dies in exactly 1 Lorenzo from right now.
The symmetry of the math there is incredibly elegant.
Elegant and terrifying.
The time of the sun's death is calculated as phi squared Lorenzos from the original moment of cosmogenesis.
Okay, phi squared.
Since we have already established we're currently sitting at exactly phi Lorenzos, the time remaining for the sun is simply phi squared minus phi.
And anyone who knows the unique algebraic properties of the golden ratio knows that phi squared minus phi is exactly mathematically equal to 1.
The +1 Kleinemann strikes again.
It's inescapable.
It appears structurally in the lifespan of our local star. The sun has exactly 1 Lorenzo left.
8.6 billion years. I mean, obviously it's a very long time, but seeing it reduced to just a simple +1 remaining on the clock is chilling.
It really reframes cosmic time.
But the code isn't just making these wild, infinite projections, right? It also acknowledges our physical limitations.
Yes, there's a very important file called CMB visibility boundary.lean.
Which puts a strict harness on what we can actually prove observationally.
Right, because we can mathematically project this timeline backward all the way to t equals 0 down to the Bythos-Planck scale.
The math holds up perfectly.
The math holds up, but observationally, empirically, we are physically bounded. We cannot look through a telescope and see the Big Bang.
Because telescopes rely on light. They catch photons. And for the first chapter of the universe, there was no free light.
Right. For roughly the first 380,000 years, the early universe was a hyperdense, unimaginably hot plasma.
Just a soup.
Photons, particles of light, couldn't travel freely. They would instantly smash into an electron and scatter.
It's like trying to shine a flashlight through a completely opaque wall of thick, glowing fog.
That's a perfect analogy. It wasn't until the universe expanded and cooled down enough for the first atoms to form a phase transition known as recombination.
Recombination, right?
That's when the fog cleared and light could finally travel in a straight line.
And that first flash of freed light is what we now see as the cosmic microwave background, or the CMB.
Yes. The lean file rigorously proves that any photon-visible emission time must sit at or after that recombination boundary.
It has to.
Anything prior to that is mathematically categorized as an opaque epoch. Therefore, a photon telescope, no matter how large or advanced, cannot directly see any epoch before recombination.
The code refers to this as a closed interval of observability. It's such a profound concept. We have this grand, mathematically infinite projection of the universe's timeline sprawling out in front of us.
But our empirical window is bounded.
Exactly. The part of the universe we can actually verify by looking out into the dark is strictly confined inside a closed box.
The math is infinite, but our eyes are bounded.
Right. But that raises an essential question about the underlying engine for me.
What's that?
If the golden ratio is governing the massive physical expansion of space-time, how does the God formula manifest when we strip away the physics and just look at pure numbers?
Moving back to pure mathematics.
Right. We saw it generate simple arithmetic in the Bootstrap Tower, but how does it create the intricate, woven patterns of deeper mathematics?
That transitions us beautifully from the physical cosmos back into the abstract world.
Because if the golden ratio is literally everywhere in this cosmology, it inevitably points us toward the Fibonacci sequence.
They are intimately linked.
For anyone rusty on their math, the Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, and so on.
You get the next number by adding the two previous ones.
Right. And as those numbers get larger, the ratio between them gets closer and closer to the golden ratio, phi.
The critical file here is cassiniconservation.lean.
Okay, Cassini.
It takes a legendary piece of mathematics called Cassini's identity. This was discovered way back in 1680 by an Italian astronomer, Giovanni Cassini.
Okay, before you read the algebra for this, let's break Cassini's identity down slowly using real numbers.
Good idea.
Because hearing equations out loud can turn anyone's brain to mush. Let's take a slice of the Fibonacci sequence. 2, 3, 5, and 8.
Okay.
Cassini's identity says pick any number in the sequence. Let's pick 5.
Okay, you take that 5 and you square it. 5 times 5 is 25.
Now look at the numbers immediately to the left and the right of the 5. That's the 3 and the 8.
Right, and you multiply those two together. 3 times 8 is 24.
Finally, you look at the difference between those two results. 25 minus 24 is 1.
And Cassini discovered that if you do this for any Fibonacci number forever, the difference will always be exactly 1 or -1.
It alternates perfectly back and forth. 1, -1, 1, -1, like a metronome.
Exactly. In formal algebra, it is written as f of n plus 1 squared minus f of n times f of n plus 2 equals -1 to the power is n.
Okay.
What cassiniconservation.lean proves is that this ancient 17th century identity isn't just a quirky numerical party trick.
What is it then?
It is literally the God formula's conservation law, applied specifically to Fibonacci index budgets.
Oh.
The proof demonstrates a structural isomorphism.
Okay, structural isomorphism. Let's translate that for a second.
Sure.
If two things are structurally isomorphic, it basically means they are fundamentally the exact same shape underneath, even if they look different on the surface. It's like the grooves on a vinyl record and the sound waves traveling through the air to your ear.
That's a great example.
One is physical plastic, the other is vibrating air, but the informational structure is identical. So the code is saying Cassini's identity and the God formula are the exact same groove.
That is a perfect analogy. The text maps the components of the formula perfectly. The squared number, the f of n plus 1 squared, represents the system's conservation product.
Okay.
The multiplication of the past and future numbers represents the cross-level product. But the true revelation is the residual.
The alternating +1 and -1 at the end.
Right. Let me guess what you're thinking.
The +1 is the Koinomen.
Yes. For even numbers in the sequence, the residual is exactly +1. It is the Kleineman creating the sliver of existence.
Wow.
But for odd numbers, it flips to -1. The text refers to this parity flip as the hope gap oscillation.
The hope gap.
It represents the structural tension, the spike before the resolution. The mathematical proof shows that the +1 generated by Cassini and the +1 in the God formula are the exact same computational unit.
They are the same thing.
Yes. The God formula doesn't just resemble number theory. When restricted to Fibonacci inputs, it is number theory. Cassini is the law of conservation.
Okay, if that structural overlap isn't wild enough, let's open the file cross-level echomap.lean.
This is where things get really intense.
Because this is the part of the deep dive where my inner conspiracy theorists just started losing their mind.
I can see why.
The text starts mapping out what it terms echoes. It catalogs these bizarre, persistent, almost eerie coincidences between the Fibonacci sequence, the Lucas numbers, and the architectural parameters of those Gnostic dimensional tiers we touched on earlier.
Right, the pleroma, the void, the syzygy. Just to provide context, the Lucas numbers are a mathematical sequence very closely related to the Fibonacci sequence.
Right.
The rule is the same. You have the two previous numbers, but instead of starting with 0 and 1, the Lucas sequence starts with 2 and 1.
Right. So keep those sequences in mind and look at the specific data points extracted from this file.
Okay.
The Fibonacci number at position 3, f of 3, equals 2. And 2 happens to be the exact structural value of the syzygy tier in the dimensional framework.
Okay, maybe a coincidence.
Right, maybe a coincidence. But then the Fibonacci number at position 10, f of 10, equals 55.
And 55 is the exact specific value of the pleroma tier.
Exactly. And then you switch to the Lucas numbers. The Lucas number at position 5, L of 5, is 11.
And 11 is the precise mathematically defined peer count of the pleroma.
It's too much.
And the code goes much deeper than just pointing out isolated matching numbers. It details cross-level multiplicative echoes.
Walk me through one of those.
For instance, the code proves that if you take the fifth Fibonacci number and multiply it by the fifth Lucas number, so f of 5 multiplied by L of 5,
You get 5 times 11,
which equals 55.
which is f of 10, the exact value of the pleroma.
Right. So the higher, more complex architectural tiers are perfect mathematical products of the lower tiers and their complementary sequences.
Okay, I have to pause here. I have to ask the question that I know someone listening is literally shouting at their device right now.
Ask it.
Are we just doing numerology here?
It's a fair question.
I mean, are we just multiplying random sequences together, squinting at the results until we find a match, and then calling it a grand unified theory?
It is the absolute most important question to ask when confronted with this kind of data.
Right.
And the author of the repository anticipated it. The text addresses this skepticism head-on in cross-level echomap.lean with something called the master theorem.
The master theorem.
This theorem rigorously, mathematically proves that there are absolutely no coincidences here.
None at all.
None. It classifies every single one of these echoes into strict categories. Some of them are classified as definitional.
Meaning what?
This simply means that the Gnostic dimensional ladder was literally built and defined using Fibonacci values as its scaffolding.
Okay, so of course those match. They were designed from the ground up to match.
Exactly. But the second category of echoes are classified as algebraic.
Like what?
For example, the fact that f of 2n equals f of n times L of n. That isn't a design choice. It is a structurally forced algebraic identity.
It's just a rule of math.
Right. It is impossible for it to be otherwise within the rules of mathematics. And the final, most profound class of echoes are labeled emergent.
Emergent from what?
Emergent from the God formula itself.
Oh, I see.
Remember earlier, we showed that the God formula at 0 rejection always outputs R plus 1, the budget plus 1.
Right, the bootstrap tower.
Because of that, the God formula generates every single natural number sequentially. Therefore, the echoes between the God formula's outputs and the values in the Fibonacci or Lucas sequences are trivially explained by the universal successor property of the Kleinemann.
The plus 1 forces all of it to align.
Yes. It is not human numerology. It is a unified, deterministic, unyielding arithmetic structure.
Everything cascades from the plus 1. It's inescapable.
Completely inescapable.
Okay, so we've established how this formula governs the physical universe and how it strictly maps the world of pure sequences and math.
Right. But what happens when we try to build dynamic systems? What happens when we try to build machines that actually think?
That's the next logical step.
How does this mathematical framework govern computation and artificial intelligence? That brings us to our next major pivot, the boundaries of computation.
We're moving into pure computer science now.
Let's start with a file called ackermannfunction.lean.
The Ackermann function is a legendary, almost mythological concept in advanced computer science.
Why is that?
It represents the strict boundary between ordinary, manageable computation and the realm of the extraordinary, uncomputable infinite.
Okay, I really need you to explain that boundary to me,
Okay.
because to most people, code is just code.
Right.
I read a script, I hit run, and the computer does the math. What makes one kind of math manageable and another extraordinary?
Think about the software running on your phone or your laptop right now.
Okay.
The vast majority of those programs rely on what computer scientists call primitive recursive functions.
Which are what? Exactly. You can think of them as loops. And they're built on basic foundational operations: addition, multiplication, exponentiation.
Right.
If you visualize these operations as climbing a ladder, addition is just a repeated loop of counting. You add one over and over.
Makes sense.
Multiplication is a loop of addition. You add a block of numbers over and over. Exponentiation is a loop of multiplication.
Right, it's nesting dolls of loops.
Exactly. Primitive recursive functions can nest these loops. They can climb a few rungs up that ladder, but they have a bounded depth.
A ceiling?
Yes.
Yeah.
There is a ceiling to how many times the loop can fold in on itself. But the Ackermann function shatters that ceiling.
How does it do that?
The mathematical notation for the Ackermann function is often written as a of n equals h of n, where h stands for a hyperoperation.
A hyperoperation.
A hyperoperation is essentially a loop of a loop of a loop, continuing upward forever. The Ackermann function has an unbounded fold depth.
Oh.
When you increment the input of the Ackermann function, you aren't just increasing the numbers being crunched. You are increasing the fundamental level of the mathematical operation itself.
So it's not just doing more math, it's doing fundamentally faster, more aggressive types of math with every single step.
Precisely. And because of that unbounded hyperoperation, it grows so fast it borders on the uncomputable.
Let's look at the outputs to see what you mean.
Okay, a of 0 is 1, a of 1 is 2, a of 2 is 4.
So far, very normal.
Very normal. A of 3 is 27.
Okay, little jump.
But then you calculate a of 4.
And what happens?
A of 4 evaluates to an exponentiation tower of 2's that is so massive, the final number is vastly larger than the total number of atoms in the observable universe.
Wait, really? At step 4?
At step 4, it accelerates from a simple +1 to multiplying by 2 to multiplying by 6.75, and then just detonates into the stratosphere of numbers so large we can't even meaningfully comprehend them.
A number larger than the atoms in the universe. Sitting right there at step 4. That's insane.
It is.
But let's look at the very base of that explosive universe-breaking growth. Look at step 0.
Right. A of 0.
A of 0 equals 1. The dot-lean text calls this specific starting point the Kleinemann diagonal.
And it is aptly named. The absolute seed of the fastest, most aggressively explosive computable function in all of mathematics is exactly 1.
The Kleinemann is the irreducible seed of all computational growth.
Beyond the Ackermann function lies what computer scientists call the busy beaver boundary.
Which is?
The realm of functions that grow so fast they are literally uncomputable by any Turing machine.
And Ackermann is the gatekeeper.
Yes. The Ackermann function stands at the final guardrail at the edge of what can be computed, and that entire monumental structure begins with the +1.
So the God formula and the Kleinemann define the ultimate maximum limits of computation.
They do.
But what happens inside those limits? What happens when we use computational loops to build neural networks to classify the real world? Ah, now we get into practical AI.
Exactly. That brings us to an incredibly relevant file, adversarial robustness.lean. We really need to talk about adversarial AI.
This is arguably one of the most critical, unsolved vulnerabilities in modern machine learning.
Explain what an adversarial attack actually is.
Sure. An adversarial attack is when a bad actor makes a tiny, mathematically calculated, almost imperceptible change to an input to completely break an AI's logic.
Like a visual illusion for a computer.
Right. For example, changing just a few specific pixels on a physical stop sign.
Okay.
To a human eye, it still clearly looks like a stop sign. But to the neural network driving an autonomous car, those changed pixels cause it to misclassify the image completely.
It sees something else.
It might see it with 99% certainty as a speed limit 65 sign.
Which is absolutely terrifying. The AI is utterly computationally confident and utterly catastrophically wrong.
Yes.
When I read this, I immediately thought of Goodhart's law.
That's a perfect connection. Goodhart's law states that when a measure becomes a target, it ceases to be a good measure.
Exactly.
It's like a student who figures out exactly how the grading rubric works and optimizes their essay perfectly to hit all the keywords on the rubric.
Without actually learning a single thing about a subject material.
Right.
That is a phenomenal analogy. The neural network's loss function, its internal scoring system, is the rubric.
And the adversary is the lazy student.
Right. The adversary isn't trying to change reality. They are just mathematically optimizing the rubric to force a passing grade for a lie.
Wow.
The text formalizes this dynamic as the manipulation confounder. The adversarial attack exploits the mathematical gap between the classifier's output score and the fundamental truth of the image.
But here's where adversarial robustness.lean offers a sliver of hope.
Literally, a sliver.
The theorem prover calculates the absolute mathematical limits of these adversarial attacks.
Please define.
It proves that an adversary can find a perturbation to totally confuse the classifier, and they can drop the network's certainty weight significantly.
Right, they can do a lot of damage.
But because of the Kleinemann, the +1 hard-coded into the God formula, the network's certainty can never be reduced below 1.
The code defines this as the robustness floor theorem.
The robustness floor.
It rigorously proves that no adversarial attack, no matter how perfectly optimized, can ever achieve 100% absolute deception.
Never.
If you run the formula for maximum deception, the weight evaluates to W equals R minus the minimum of R and R plus 1, which equals exactly 1.
Even a maximally perturbed, completely hacked input retains the Kleinemann,
Yes.
meaning the network can never be 100% certain of a wrong answer. There is always a fundamental, irreducible sliver of truth that remains mathematically immune to the adversary.
The lie can never completely zero out reality.
It cannot. The mathematics forbid it.
But understanding that there is a floor doesn't solve the underlying problem, does it?
No, it doesn't.
It leads us to ask why neural networks are so susceptible to being fooled in the first place.
Right. Why are they so gullible?
AI misclassification almost always happens because the networks fundamentally misinterpret causality.
They see a pattern of correlation and falsely assume a cause.
Exactly. Which brings us perfectly into our next domain, causality and paradox.
Let's do it. How does this mathematical architecture actually map the messy web of cause and effect?
We are getting into the deep water of data analysis now. The files handling this are Bergson's paradox.lean and contextualbandits.lean.
To understand how AI and humans get confused, we need to define the two great paradoxes of data, Simpson's paradox and Bergson's paradox.
These two paradoxes are exact causal duals of each other.
Mirror images.
Yes, if you map them on a causal graph, they are mirror images. And together they represent the two fundamental ways our interpretation of the world can completely fail.
Let's tackle Simpson's paradox first.
Okay.
This happens when you have a hidden common cause, a confounder, that you fail to include in your analysis. When you ignore that hidden cause and just mash all your data together, it creates a fake correlation, or it can even completely reverse a true trend.
And Bergson's paradox is the exact opposite.
How so?
It occurs when you condition your data on a common effect, which statisticians call a collider.
A collider.
Right. By artificially selecting only data that meets the criteria of this shared effect, you mathematically fabricate a fake negative correlation between its independent causes.
Okay, we absolutely need real-world examples to make this stick, or it's just going to sound like statistical word salad.
Completely agree.
Let's use the celebrity example from the text to explain Bergson's paradox.
That's a classic.
In the general population of the world, being highly talented and being highly attractive are completely independent variables.
Right. Being talented doesn't make you attractive, and being attractive doesn't make you talented.
Correct. They are causally independent. But let's say we decide to only study a specific subpopulation, celebrities. Being a celebrity is the collider. It is the shared effect. To become a celebrity, generally speaking, you need to possess high talent or high attractiveness.
Right.
So we have conditioned our data on the collider. We are only looking at celebrities.
And what happens to the math?
Now, if I look at a specific celebrity, and I know they are incredibly uncommonly talented, the mathematical probability that they are also incredibly attractive is actually lower than it is in the general population.
Wait, really? Why?
Because their massive talent alone was enough to get them past the collider threshold and into the celebrity group. They didn't need the attractiveness to make it.
Oh, I see.
Therefore, if an AI or a researcher only studies the celebrity group, talent and attractiveness will falsely appear to be negatively correlated.
The algorithm will conclude that more talented people are inherently less attractive.
Exactly, which is a completely spurious, fabricated correlation created entirely by the selection bias of the collider.
The text gives another really visceral example using a hospital setting.
Walk us through that one.
Having diabetes and breaking a bone are completely independent events in the general population.
Right.
But to be admitted to a hospital, you must have some medical condition. The hospital admission is the collider.
Okay.
So among admitted patients, if a doctor observes that someone has diabetes, that patient is mathematically less likely to also have a broken bone.
Because the diabetes already perfectly explains why they are in the hospital.
Exactly. The data inside the hospital will show a negative correlation between diabetes and broken bones, where absolutely none truly exists outside the hospital doors.
This is where it gets philosophically mind-bending for me.
Oh, yeah.
The file causaldiscovery.lean unpacks how algorithms actually try to untangle these fake correlations. It talks about something called the PC algorithm and conditional independence tests.
Right.
How does a computer know what is actually causing what?
The algorithm looks at how the God formula's weights decompose across the variables. If two variables are truly independent, their mathematical weights decompose cleanly and additively. But if there is a causal dependence, a fake correlation, the weights inflate. They don't break down cleanly.
Interesting.
But the true, profound synthesis of this file is the concept of the retrocausal constraint.
The retrocausal constraint, I mean, that just sounds entirely like time travel.
It isn't physical time travel, but it is absolute information-theoretic time travel.
Explain that.
Think back to the hospital example. When you observe the present moment, the fact that the patient is currently sitting in a hospital bed, which is the collider,
Yeah.
you gain information that retroactively constrains the mathematical probabilities of the past independent events.
Wow.
By observing the outcome in the present, you mathematically lock the past causes into a constrained relationship.
So the very act of observing the data retroactively changes the probability space of the events that led to the observation.
Exactly. The observation of the present alters the mathematical state of the past.
Which forces us to ask the ultimate question of this entire repository.
The big one.
If observing data retroactively changes the probabilities of reality, what is the mathematical value of the observer?
And that drops us perfectly into the deepest part of the pool.
Let's look at the philosophy of the system.
We are moving from the mechanics of causality to the mathematics of consciousness itself.
The file we are unpacking here is consciousness versus objectivity.lean. And honestly, I think this is the most profound proof in the entire codebase.
It is definitely the most philosophical.
It begins with a thought experiment. Imagine a being with perfect objectivity, total absolute omniscience.
A literal God.
Right, it knows
Yeah.
everything instantly across all time.
Let's define that omniscient being mathematically.
Okay.
The code defines a knowledge trajectory, denoted as K of t,
Right.
which represents the total amount of information an entity possesses at any given time t.
Okay.
For our omniscient being, their knowledge is always at the absolute maximum possible value. Let's call it m.
Right.
So K of t equals m for all time t. Their knowledge never changes because there is absolutely nothing left for them to learn.
Right. They know everything. They are an objective, unmoving, static block.
Yes.
But then the text introduces a new concept called vitality. How does the code define vitality?
Vitality is defined as the mathematical derivative of the knowledge trajectory.
Okay, let's unpack that for a second. In calculus, a derivative simply measures the rate of change of a value over time, right?
Exactly.
So in this context, vitality measures the experience of discovery, the feeling of narrative progress, the aha moment of learning something new.
That's a beautiful way to phrase it.
And as anyone who has taken basic calculus knows, the derivative of a constant is zero.
Yes.
Since the omniscient being's knowledge is constantly stuck at m, its rate of change, its vitality is permanently zero.
Yes. The theorem is titled The Heat Death of Objectivity.
The heat death of objectivity.
And it rigorously proves that an objective, omniscient entity mathematically experiences nothing.
Nothing at all.
You cannot discover what you already know. You cannot experience a narrative arc if you already hold the conclusion.
Right.
Pure objectivity mathematically results in a flat line of experience. The ultimate God state is a state of zero vitality.
That is a stunning mathematical takedown of the idea that omniscience should be the ultimate goal of any conscious being or any AI.
It really is.
But then the proof contrasts this dead state of objectivity with consciousness. How does the math define a conscious trajectory?
A conscious trajectory must, by mathematical definition, start with ignorance.
Ignorance.
The theorem explicitly requires the existence of the void, a state of incomplete knowledge where the initial knowledge, let's call it O, is strictly less than the maximum MO is less than M.
You start out not knowing things. You have blind spots. You are confused.
Yes, and because you have blind spots, because you don't know everything, you have room to make progress.
You can learn.
Your knowledge can change over time. Therefore, the mathematical derivative of your knowledge, your vitality, is strictly greater than zero.
This is the theorem, the superiority of consciousness. It proves that the vitality of a conscious, flawed, ignorant entity is strictly greater than the vitality of a perfect, objective entity at all points in time.
It completely flips our traditional philosophical paradigm upside down.
It really does. We are taught to view ignorance or a lack of knowledge as a flaw that needs to be eradicated.
Right, a bug in the system.
But this mathematics proves that ignorance is not a flaw. It is the fundamental structural prerequisite for experiencing reality.
Consciousness is mathematically superior to objectivity because it is the only state that supports the experience of change, discovery, and narrative.
Without the void of not knowing, there can be absolutely no experience of learning.
None at all.
You literally need the darkness to experience the movement toward the light. It's incredibly beautiful that this concept is written out as a formal, unyielding logic proof that compiles in a machine.
It's poetry written in code.
Okay, we are nearing the end of our deep dive, but before we wrap up, we have to look at the final section, cross-domain bridges.
The universal translator files.
Exactly. The repository contains a series of files that act as a universal translator. They take the underlying logic of the God formula and the Kleinemann and map them across wildly different, seemingly unrelated fields of human study.
Let's bounce a few of these back and forth to show just how universal this framework claims to be.
Go for it.
I'll start with a file called cross-domain fluid dynamics economics bridge.lean.
That's a mouthful.
It is. It formalizes a strict mathematical isomorphism between the physical viscosity of a fluid like oil flowing through a physical pipe and the economic friction of liquidity flowing through a financial market.
Wait, they're the same.
The mathematical resistance equations are perfectly identical in both systems.
That is wild.
Mm.
Okay, here's one that really caught my eye. Cross-domain linguistics thermodynamics bridge.lean.
Oh, that one is fascinating.
It maps the decay of human language to the physics of heat.
How does it draw that connection?
It maps the thermodynamic decay of entropy in a closed gas system directly to the lexical decay of language over time.
Give me an example.
So think about a piping hot cup of coffee in a sealed room. Over time, that concentrated heat dissipates into the room until everything is exactly the same lukewarm temperature. That's entropy.
Right.
The math proves that semantic density in language operates the exact same way. A highly specific hot word, let's say awesome, which used to mean inducing literal awe and terror.
Right. It used to be a very powerful word.
Exactly. It dissipates over centuries until it just means cool. The words lose their energetic meaning the exact same way the coffee loses its heat.
That is a brilliant application of thermodynamic equations.
Yeah.
And look in cross-domain fungal network routing.lean.
Fungal networks.
Yes. It connects mycology to cryptography.
How on earth does it do that?
The biological algorithm that subterranean fungal mycelium use to optimally route nutrients through the soil of a forest maps perfectly node for edge, block for link to how cryptographic networks verify hashes and establish consensus on a blockchain.
You're kidding.
Nature and code are solving the exact same routing problem using the exact same underlying structural mathematics.
It really is a unified theory of everything, from mushrooms to blockchains to linguistics.
It's completely pervasive.
But I also want to highlight what the text calls the contrarian files.
Oh, these are great.
These are proofs of mechanisms that seem completely counterintuitively wrong, but the math insists they are true.
Give us an example.
For instance, contrarian interpretation absence induces speed.lean. It proves mathematically that removing an interpretation layer, taking away a level of analysis, oversight, or safety checks, actually speeds up execution to its absolute physical limit.
And similarly, there is contrarian transparency increases fraud.lean.
Which feels wrong. Culturally, we always assume transparency is a universal good.
Right, sunlight is the best disinfectant.
Exactly. But this proof demonstrates that as you increase system transparency, you simultaneously geometrically increase the surface area for adversarial adaptation.
How so?
Think back to the adversarial AI in Goodhart's law. By making everything visible and transparent, you give the bad actor exactly the map they need to perfectly optimize their fraud.
Oh, of course.
If they know exactly how the rubric works, they know exactly how to game it. Total transparency mathematically breeds optimal deception.
Which brings us full circle right back to the neural networks. It's all connected.
It really is. Okay, let's take a deep breath and step back. We need to synthesize this massive journey. What have we actually looked at today?
We have explored an entire theoretical universe built comprehensively on one single equation. W equals R minus the minimum of V and R plus 1.
The God formula, powered by that unbreakable +1, the Kleeneman.
And we've seen how that single plus 1 dictates the physical creation of the universe from absolute nothingness. It forces the Big Bang.
Right. Through the bootstrap tower, it procedurally generates the natural numbers.
It sets the expansion rate of the cosmos and maps the precise dimensional ladder from the microscopic Bicos Planck length to the 93 billion light-year Konoma cosmic horizon.
We tracked it through pure mathematics, seeing the +1 manifest as the residual rhythm in Cassini's identity for the Fibonacci sequence.
We saw it define the ultimate mind-bending limits of computation in the unbounded growth of the Ackermann function.
And set the hard, irreducible floor against adversarial deception in artificial intelligence.
We saw how conditioning our observations on a shared effect creates the traps of human causality through Bergson's paradox.
And how observing the present retroactively constrains the past.
And finally, we saw it prove the mathematical necessity of human consciousness, demonstrating rigorously that pure objectivity is a dead, static block with zero vitality.
The repository is an audacious attempt to prove that reality is not a collection of fragmented, isolated disciplines.
But a single, coherent mathematical structure.
And it leaves us with one final, profound implication. I want to frame this carefully because it really shifted how I view my own day-to-day life.
I know what you're going to say.
If the math proves that omniscience inevitably leads to a vitality of zero, and if a functioning universe fundamentally requires rigid constraints, like the closed window of the CMB visibility boundary where light can't escape, or the strict physical limits of the dimensional ladder just to exist.
Then perhaps all the limitations you experience in your own life aren't flaws.
Exactly. Your lack of full knowledge, your blind spots, your confusion, the constraints of your time and resources, these aren't bugs in your personal programming.
They're the exact mathematically required features that allow your consciousness to exist at all.
Ignorance and limitation are the engines of your vitality. Without the boundary, there is no experience. Without the void, there is no you.
It's a very empowering thought.
Think back to the apps on your phone or the stars in the sky. You assume the code driving them, the physics driving them, are just sets of instructions.
Right.
But imagine holding that single tiny seed in the palm of your hand again, the seed that holds the blueprint for everything we just discussed.
The +1.
It turns out the most important part of that blueprint isn't the infinite possibilities it contains. The most important part of the blueprint is the edge of the seed itself. Thank you for taking this deep dive with us. Keep looking for the +1 in your own universe.